Assalamu alaikum students. As we have read lastly that algorithm for these very electric current conductors, and then we read about the drift velocity. We said that in absence of the electric field, the electrons are having a thermal speed of the order of 10 raised power 5 to 10 raised power 6 meters per second, but there is no net flow of electron, and hence electric current is zero in absence of electric field. But once the electric field is applied, the electrons move uh, opposite to the direction of electric field, because direction of electric field is positive to negative, but electrons move towards the positive, that is opposite to the direction of electric field. And we find it out first that the average velocity in absence of electric field, the average velocity of electron is zero. But as now there is applied voltage, there is potential, there is battery applied, the free electrons in the conductor get drifted in a direction opposite to the electric field, and that is known as the drift velocity. That is very small. Why that is small? Because I told that's of the order of 10 to the power minus 3 to 10 to the power minus 4 meters per second. Drift velocity is very small. Why it is small? Because there are collisions, the electrons which move in a particular direction, as this is the conductor, and now the electrons which are moving in a particular direction, if this is positive, this is now negative, this is a cross section, and these are the electrons. Now they are moving, but they get collided with the atoms or the constituents which are already of which the material is made. Once they get collided, so their acceleration, as the electric field is applied, they are having an acceleration, but that acceleration remains for very small time. This electron, once it leaves, it moves, then it gets collided with this. Once it leaves it gets again accelerated, but it gets collided here with the another constituent of the material. Then once it left, it gets collided with another which is present in the material. So now what we have to do, we have to derive an expression for the drift velocity. As we are aware that drift velocity is the velocity, average velocity with which free electrons in the conductor drifted in a direction opposite to the direction of applied field. Now as the electric field is applied, on application of electric field, what we are having, the force experienced by free electron is F equals to minus E into E. This is the force experienced by free electron. But this is experienced once there is application of electric field. Now negative sign here shows that force F and E, they are opposite direction. E is in this very direction, but F is in this very direction. This is the direction of F and this is the direction of E. Electric field and force. So now as there is force, so there will be acceleration. The acceleration, now acceleration produced in electron is given by, how much will be that? Then acceleration equals to what? F by m, because from Newton's second law of motion, where F equals to m into E, then A is equal to F by m, where m is the mass of electron. Now therefore we can change this A, which implies acceleration A equals to what? It equals to minus E, instead of F I will put E, or it will be simply m. Now what, as this acceleration remains for very small time, because when the accelerated electron collides, this accelerated electron, this is the electron, this moves. Once it moves, it reaches here, it gets collided. Now after collision, it will get accelerated again, but it gets collided with this. The time between, if this is one constituent, this is another constituent of the atom, and this is the electron, the time between two collisions, the time between two successive collisions, that is called as the relaxation time. There is a small interval of time between two successive collisions between electron and the ion. The this electron, once it left it reaches it, but this is a very small time between these. This is a gap. This is a very small time between two successive collisions. There's a small time, and that time is called as what? Relaxation time. Relaxation time, or mean, or it's called as mean free time. So what we have to understand, we'll get the expression, but what we have to understand that there is a collision, and after the collision there is a small time before the another collision takes place, and that time is called as the relaxation time. And in other words, we can say that the electron accelerates for very small interval of time. Why it accelerates? Because between these two very collisions there is a small interval of time. It is not that one collision takes place now the next will not take place, but next takes place very quickly. So this very the time between two successive collisions is called relaxation time. In other words, we have to say there is a small drift velocity, and that very drift velocity then is given by Vd. Drift velocity equals to what? U plus acceleration into tau time. Now it is 0. So Vd, the drift velocity, equals to what? It will be minus E by m and tau, where this is called as relaxation time, mean free path over root mean square value. This very tau, it depends upon what I mean to say temperature. Tau decreases with the increase in temperature. This tau decreases if temperature is increased. Tau decreases. Why tau decreases? Because there will be more and more, what I mean to say, that increase the root mean square, VRS MSS increases, which increase the temperature. So tau decreases with increase in temperature. Actually what I am saying, that with the increase in temperature, once temperature increases, this root mean square, this very tau, it decreases. With the increase in temperature, this very tau decreases. So we can say Vd is directly proportional to what? You can see it's inversely proportional to temperature. More temperature, less will be this. Less will be this very relaxation time. Once relaxation will be less, that will be there will be more and more collisions. There will be more and more simply because these very constants are going to vibrate more and more. Once they are going to vibrate more and more, then relaxation time is going to get decreased. This is the equation which you have to remember, and this is the factor which you have also put within your mind. This is all for today. Tomorrow will be another lecture. Till then, Allah Hafiz.